Alright, today we're going to be talking about a chemical equilibrium and what that might look like. Alright, so we have two graphs here. One of them is showing the concentration of the products and reactants, and then also the time. Okay, so this first one here is concentration and time. Now time is the same on both graphs, they're both on the x-axis, but this bottom one showing the rate as well. Alright, so the definition of chemical equilibrium is when the rates of the forward and the reverse reaction are actually equal. So if we look at the bottom one here, we can see that there is a forward reaction and a reverse reaction. Forward and reverse. Now, this is the rate on the y-axis. So the point where those rates are the same, which is this section here, that represents that equilibrium has been reached. So the rate at which, the point at which the forward reaction and the reverse reaction are at the same rate, that means that the equilibrium has been reached. Now the same thing is happening up here, but this time we're looking at concentration instead of the rate. So the concentration of reactants can be different at equilibrium. So equilibrium is achieved at about this point here. So at this time forward, the system is at equilibrium. Now the reason they're at equilibrium is because those concentrations aren't changing. So the concentrations stay the same from that point onwards. And that indicates that the rate of the forward and reverse reaction are actually the same. So for example, if we have a general form for a chemical equation, is this here, and the reverse reaction is that way and the forward reaction is this way. So we have the reactants on the left and the products on the right. So the rate of the forward and reverse reactions are occurring at the same rate. So C and D are becoming A and B are becoming C and D at the same rate at chemical equilibrium. Okay, so hopefully that makes a bit of sense. It's a very quick introduction to chemical equilibrium.